We're going to face a unique risk when we deal with deep space exploration. Earth right now is protected from galactic cosmic radiation, or GCR, through the Earth's electromagnetic sphere. But once we leave that, we will have to try to address this risk. So what we do at TRISH, we are a funding agency that partners with the Human Research Program at NASA, and we're tasked to look for those bold projects, those big ideas, those disruptive technologies that, if successful, can really change how we approach deep space exploration. So radiation can be a significant risk, or a primary risk, what we call a red risk, for people when they go out into the deep space environment. What's unique about deep space exploration is once you leave that Van Allen belt, or the Earth's electromagnetic sphere, is you get exposed to something called galactic cosmic radiation. We don't really know what will happen to humans, to human tissue, to function, to cognitive ability, to behavior, once we have that low-grade exposure to this unique source of radiation. There are different ways we can do this. One is we can start to look at more complex human in vitro models. So looking at human tissue and the physiological response to radiation exposure for these types of radiation particles. We can also look at technologies on how to understand how much dose we're getting, how much does each individual person get, and are there ways that we can personalize biomarkers or understand exactly how each individual is responding to this low-grade exposure to GCR, or again, that galactic cosmic radiation. So there's a lot of approaches to how we can detect and monitor that we're very interested in developing. Now, on the other end, we're also going to be very interested on countermeasures. So as people are getting exposed to this GCR, unique deep space type radiation, how can we protect humans against this exposure? So we're looking for technologies that will help with this countermeasure. A lot of times people are thinking about pharmaceuticals or nutraceuticals, and what I mean by that are antioxidants or drugs that could protect against radiation. So these could be radiation countermeasures, but we're also looking for technologies that could help. So are there materials, are there shielding capabilities that could help protect or mitigate the amount of radiation that we get exposed to during deep space exploration? So a technology called tissue chips, or organs on chips, microphysiological systems, they all mean something very similar, which is zooming in on the microenvironment of an organ or tissue of interest and trying to mimic that environment in the different cells and the scaffolding that the tissues would be in an vivo environment, and having that as a way to study physiological response for radiation exposure, but also other risks, looking at the immune response. So these tissue chips can be used not only for just radiation studies, but a number of different risks that are associated with deep space exploration.